Okay, so anytime we're evaluating a limit algebraically, our first step will be to try direct substitution, plugging the number into the expression. If we get a number back from that, that's the limit, no big deal. But for a lot of the important limits in calculus, that's not the case. So we're going to talk about what to do if you get something that's not just a plain number. And the first thing you'll see are what's called an indeterminate form. Indeterminate forms tell you that you need to do more work, that you can't tell the value of the limit from what you've gotten. And the first indeterminate form we're going to talk about is 0 over 0. So let's see how this looks in practice. When I do my direct substitution here, if I plug in 2 on top, I get 2 squared minus 4, which is 0, and then over 2 minus 2, which is 0. Now notice I'm not putting an equal sign there because it's impossible for a limit to equal 0 over 0. This indeterminate form means the limit's value can't be determined from the work that we've done. We have to do further exploration. So there are several strategies you can use to attack limits like this. And the first one we're going to talk about is factoring and canceling. So I've got this limit. You notice when I plug in 2, I get 0 on top and bottom. And the reason I get 0 on the bottom is because I have a factor of x minus 2 on the bottom. Well, that means that since I'm getting 0 on the top, I also have a factor of x minus 2. And if you think about x squared minus 4, it factors into x plus 2 and x minus 2, right? So now that I've factored it, you see this factor here, the x minus 2, that was giving me the 0 on top and bottom, can be canceled. And now I can try direct substitution again. When I do it this time, and I'm showing an extra step just to be clear, I plug in 2 for x this time, I get 2 plus 2, and my limit will approach 4. Now just a word of like, not warning, but like clarification. If I were to ask, if I had this as a function, and I were to say, what's f of 2? If I plugged 2 into the function, I get 0 over 0, which is undefined. But because I'm talking about a limit, when I cancel that, and I do the direct substitution, I'm actually finding the y value that it approaches. So what would happen in this graph is the y values would get close to 4, but there would be a hole at that point. So whenever you get 0 over 0, you can start by trying factoring and canceling. This especially works if you have polynomials on top and bottom.